So 5.1, we're going to start working with polynomials. Before that, we're going to introduce monomials. And while a polynomial is many terms, a monomial is just one term. So you guys have done powers before, like exponents, when we did the order of operations. So what we're going to be doing in this lesson is we're going to multiply, divide, and simplify monomials and polynomial expressions. Okay, so this first part is going to be all about monomials. So what we're going to be doing a lot of simplifying. So when we talk about simplifying, what that means in like official math language, to simplify an expression, if there are powers involved, it means to rewrite the expression without parentheses and without negative exponents. All right, so what we're going for here is we want to rewrite the expression without parentheses and without negative exponents. Okay, so that's our end goal. So we've got a bunch of properties. So the properties start off like this. For any real numbers x and y, and then integers a and b. So in these properties, I'm going to be using x, y, a, and b. So x and y can be absolutely anything. A and b have to be integers, meaning no fractions or decimals, just positive and negative whole numbers. All right, so the product of powers works like this. Say you've got x to the a, and then you're multiplying it by x to the b. So if you've got the same base and then you've got two different powers, this first property tells us that we add those exponents together. Okay, so we're going to apply that property later. Quotient of powers, if we've got x to the a divided by x to the b, this next property tells us that with a quotient like that, we subtract the powers. Okay, and again, these will all make a lot of sense once you see them in action, and I know you've seen them before. Negative exponent, if you've got this, like x to the negative a, remember a negative exponent represents the multiplicative inverse of a number, so we write this as 1 over x to the positive a, or if for some reason you ever see a negative exponent in the denominator, you would flip it up into the numerator as a positive exponent. Okay, so basically anytime you see a negative exponent, you flip it to the other piece of the fraction. Okay, power raised to a power. Let's say you have x to the a in parentheses, and then you raise it to the power of b. In this case, you multiply those together. So this one and this one are most commonly confused. With this one, you would have to have two separate bases. That's when you add them. Here, a power raised to a power is when you multiply them. Power of a product. So let's say you've got a product, x, y, and then you're raising that whole product to a power. If you're multiplying on the inside here, you can distribute that power. Like that. You can't distribute a power over addition, but you can distribute a power over multiplication. And then this is super similar. If we've got a quotient like this, raised to a power, you raise the numerator to the power and raise the denominator to a power. Okay, and then our final property that we're going to be working with is the zero power. If you take anything at all, and raise it to the zero power, you're going to get 1. Doesn't matter what it is that you're raising to the zero power. Okay, so those are your properties. We're going to work with all of those on the next page here. We're going to run through and do some examples here. So I reminded you guys on the previous page, but remember that a monomial, it's either a number, a variable, or an expression. It's just a product of one or more variables with integer exponents. So it's just a product of numbers, variables, with non-negative integer exponents. So the non-negative part we'll get to when we write down our rules right here. All right, so basically a monomial is just one term. The mono part means one, and so there's no addition or subtraction. With polynomials, we'll have addition or subtraction of multiple terms. So when we're simplifying monomials, which is what we're going to be doing for the rest of this video, we've got a list of rules that we need to follow. So we know we're in simplified form when the following things are true. There are no powers of powers. We can't have that. So like what we have in part D down below is a no-go. Can't have powers of powers. Each base appears exactly once. So a bunch of these don't work. See, you've got the A in a couple different spots. Here you've got C and D in a couple different spots. That means you're not simplified yet. All fractions are in simplest form. And finally, this is what I said was coming up, there are no negative exponents. Okay, so let's go through and do some examples. I think you guys have probably seen these before. Assuming that no variable equals 0 just keeps us from ending up with 0 in the denominator, because we know we can't have 0 in the denominator. Okay, so what we're going to do is these all just get multiplied together, because you've just got a term times a term times a term. So no powers of powers. We actually don't have any of those issues here. Each base appears exactly once. Okay, so we've got this A, and this A appears more than one time. So when you have two separate bases with different powers, our first property on the front tells us that we add them. So this, for A, we add these exponents together, and we have -3 plus 2. We'll simplify that in a moment. B to the fourth, so B only appears once, C only appears once. Okay, so we're just kind of going through and checking these items off the list. All fractions are in simplest form. We don't have fractions, so we're not worried about that. No negative exponents. Okay, so let's work on that part next. This simplifies up to a to the negative first. I just combine these up. B to the fourth, C to the first, negative first. So what you do with these is, since they're negative exponents, you flip them down to the denominator. So B to the fourth is positive, so it gets to stay right here. And then A to the first flips down here, and I don't have to write the first power. It's kind of implied. And then C to the first gets flipped down there too. So that would be my final answer. You can kind of run through the checklist and see that all 4 of those are checked off. So that means this is in simplest form. Okay, this one, let's do the same thing. No powers of powers, we don't have that. Each base appears exactly once. That's what we need to take care of here. So first thing is, with these numbers, I can reduce the 15 over -3. So if you divide them both by -3, here you're left with -5, and this cancels. So I have a -5, and then for both of these, I can use my quotient property where I subtract the exponent. So for C, I'm going to subtract 5 minus 2, and that'll be my new exponent. And then for D, I'm going to subtract 3 minus 7, and that'll be my new exponent. So I'm working on step 2 here, but I really kind of just fixed step 3 with that 15 over -3 as well. So this simplifies. I've got -5. C's new power is 3. That's 5 minus 2. D's new power is -4. Okay, last thing is I can't have negative exponents, so I'm going to flip that down to the denominator. Okay, that would be your final answer. All right, let's look at part C. C, I have this quotient property, where if I've got a quotient raised to a negative exponent, not a negative exponent, any exponent, I can distribute that exponent. So I have a to the -3rd over 4 to the -3rd. And then since they're both negative exponents, I'm actually going to swap them both. So I'll have 4 to the positive third in the numerator and a to the positive third in the denominator. And then 4 thirds, or 4 to the third, 4 times 4 times 4 is 64. Okay, last one in this video. I have this squared power that I can distribute to everything. So distribute it here, 3 squared, then a cubed squared over b to the 4th squared. Okay, 3 squared, I know what that is. That's just 9. Another property tells me if I have a power raised to a power, I can multiply them together. So 3 times 2 gives me a new power of 6. And then same thing here. 4 times 2 gives me a new power of 8. And that would be my final answer. Okay, in the next video, we're moving on to polynomials. Okay, in the second video, we're dealing with polynomials. So we did monomials. Polynomials are basically just addition and subtraction of monomials. So here's what we've got. So addition or subtraction of monomials. And then remember, the important thing to remember about monomials is that you have non-negative integer exponents. Okay, so any exponents that you're dealing with have to be non-negative and they have to be integers only, meaning no decimals, no fractions, whole numbers. Okay, so this example, we're going to be just determining whether each expression is a polynomial. So it's a yes or no. Then we can talk about the degree if it is. So here, this is actually a no. So here we've got just a normal expression. Its exponent is 4. That's an integer. And then here you've got a square root. There's no room for square roots in the definition of polynomials. So no, and then the reason to keep in mind is that you can't have any square roots. So square roots are not a non-negative integer exponent. They're kind of this other thing that we're going to categorize later, but just know for now that they are not integers. Okay, this next one, negative 16p to the 5th. Okay, that's a non-negative integer exponent. P squared, t to the 7th, 2 and 7, neither one of them are negative, they're both integers, so yes, this is. And then what the degree is, I think you guys have done this before, it's the largest power. Okay, so this term right here has a power of 5, there are 5 p's. This term right here actually has a power of 9, there's 2 p's, 7 t's, which makes for 9 total variables in that term. Okay, so the degree of this one is 9. Okay, so again, we just get that by combining all of the total variables up. 2 here, 7 here, we just add those together. Okay, this next one, x squared, okay, the 2 works. Negative 3x to the negative first, that's a problem. There's a negative exponent right there. Okay, so the reason this was not a polynomial is because we had a negative exponent. Okay, so that's that first part, just learning to categorize them. Now we're going to work with them. We're going to add, subtract, multiply, and divide. So just, I'm sorry, we're not going to divide, just the 3, addition, subtraction, and multiplication. So this one I'm going to show you guys 2 different methods. One method, we can kind of just leave it all horizontal like this, and we just combine up like terms. So we've got 2a cubed minus a cubed. So 2a cubed minus a cubed. All I'm going to do is just rewrite and kind of group them differently, and then we can simplify. 5a, positive 5a, minus, don't forget that minus in the middle, it works for all of them, and then negative 3a. And finally a negative 7 on the left minus positive 2. Okay, so now we're just going to combine up all our like terms. So we've got like terms here, here, and here. We just want to clean those up. So 2a cubed minus a cubed leaves us with an a cubed. And then 5a, this turns into plus a positive, so that's an 8a. And then negative 7 minus 2 would be negative 9. So that would be your final answer. That's all you really have to do is combine up like terms. Be very, very, very careful anytime you're dealing with subtraction. You got to make sure you subtract every term. Okay, I'm going to show you an alternate method here. Some people work really well with kind of getting a nice visual of how these are being added together. So you can take both of these terms, write them in decreasing order, so highest powers first, and then plus, and just line the matching terms up right underneath, like that. Okay, and then the combining like terms is really easy because they're all lined up right on top of each other. So combine these up, and I would have a 2x squared. Combine these up for a negative 14x, and then combine these up for a negative 3. So 2 different methods, whichever one clicks with you, great, do that one. So is the set of polynomials closed under addition and subtraction? So what closure means? Closure means that if you add 2 polynomials together, what you get is still a polynomial. And closure under subtraction means if you subtract one polynomial from another, what you get is still a polynomial. So I added 2 together, this is definitely still a polynomial. And I subtracted, I'm sorry, this is adding, and this is definitely still a polynomial. This is subtraction, this is definitely still a polynomial. So yes, absolutely. If I add or subtract 2 polynomials, the result that I get is still a polynomial. So that's what it means to be closed. Okay, so now this one, this is multiplication, but it's more like distribution. So we've got 2 types of multiplication. One is a little bit simpler where all you're doing is distributing one term, and then down here we're going to do the more complicated. Okay, so here, this, we're going to distribute that y to everything. So negative y times 4y squared. So the negative gets distributed. I know I have the 4, and then y times y squared. Remember, I add the powers. So I have a power of 1 plus a power of 2. So that gives me y cubed. Okay, then distribute the negative y here. I know it's going to be negative. I have the 2 from this term right here. And then y times y, I add the exponents together, and I get y squared. And finally, negative y times negative 3. The negative times negative makes it a positive, and it's just 3 times y. So that would be your final answer. And now notice that is, again, still a polynomial. Okay, next, we got a little story problem here. Small online retailer says the cost associated with X units is given by this expression right here. So that's a cost expression. The revenue is given by this expression. Write a polynomial to represent the profits. Okay, so we've got this formula right here. That's like some econ stuff, I guess. So the profit is revenue minus cost. So we want to get the profit, and I'm going to write it in function notations. The P stands for product. So we take the revenue, which is given by 10x, and then minus the cost, which is given by this expression right here. So just like the one up above, since we're subtracting, be super, super careful. Make sure every term gets subtracted. So this equals, I've got 10x minus 5x, so that's 5x. And then nothing else combines with like terms. I'm just going to subtract it. So minus this term, and then minus 500. So make sure you are distributing that subtraction. So that is your profit expression. Okay, last thing we're doing is we're going to take products. So products are like foiling. You basically take each term over here and multiply it by each term over here. So start with a squared times a. So a squared times a is a cubed. Then a squared times 2, which is 2a squared. Then move to the next term, the 3a. 3a times a is 3a squared. 3a times 2 is 6a. And then finally, the negative 4. Negative 4 times a is negative 4a, and negative 4 times 2 is negative 8. Okay, so it's like foiling, but a little bit more extreme because we've got 3 terms over here. So now we're just going to combine all the like terms. The only a cubed is this first a cubed, so I got that. 2a squared, 3a squared, I add those together, I get 5a squared. Okay, so we got those. Now nothing's canceling, I'm just kind of keeping track of what I've written down so far. 6a minus 4a combines to a positive 2a, so I got those. And then minus 8 is my only constant. Okay, so I grabbed all my like terms, combined everything up, and that's what I get. Okay, for part B, I am going to set this up like I did in example 3b up above, kind of like a linear, vertical sort of thing. See if that works for you. So again, parts A and B, I'm just providing you with 2 different methods. Whichever one clicks works. So this is like multiplying big numbers together. You start with this one. So you multiply negative 1 times 5, and you get negative 5. Then multiply negative 1 times negative 4x, and you get positive 4x. And then multiply negative 1 times 2x squared, and you get negative 2x squared. So I'm assuming that looks familiar, kind of from the way that you multiply 2 or 3 digit numbers together. And then, remember, you put a 0 as a placeholder here. And then we move to the 3x. So 3x times 5 is positive 15x. 3x times negative 4x is negative 12x squared. And 3x times 2x squared is 6x cubed. Oops, cubed. Sorry, it's a weird 3. Okay, so then we just combine them up vertically like this. So I get a 6x cubed. Add these up, and I get a negative 14x squared. And then add these up, 19x, and these, negative 5. Okay, so again, 2 different ways. Whatever clicks for you is totally fine. And last question, are polynomials closed under multiplication? So just like above, if I multiply 2 together, do I still get a polynomial? These are clearly still polynomials, so the answer is yes.